a first lesson from Chapter 3. Chapter 3 is all about real numbers and the coordinate plane. Today's lesson on 3.1 is exploring square roots and irrational numbers. So first we've got some vocab. A number that is the square of a whole number, such as 4, 9, 16, 25, and 36, is called a perfect square. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. All these numbers are perfect squares, and you really would want to try and memorize them. 19 is not considered a perfect square because it is not a whole number times itself. It does not equal that. So there's perfect square. Our second vocab word that you need to know, a number that you can multiply by itself to get a given number is called the square root. This is how we draw a square root symbol. Okay, so both 4 and -4 are considered square roots of 16 because 4 times 4 is 16 and -4 times -4 is 16. However, for the purposes of this book, whenever you see something written like this, you will always take the positive square root of it. So the positive square root of 25 is 5, even though -5 times -5 is also 25. You should memorize all the perfect squares. This will allow you to estimate a square root. Let's look at an example. To estimate the value of the square root of 28. Step 1, find the perfect square right above and right below the given value of the square root of 28. Step 2 will be to write the whole number of the square root of the one below it. Step 3 is to estimate a decimal by how close or how far it is to the other perfect square. So let's look at it. We have the square root of 28. So I know that 25 is the next perfect square that's below it, and 36, 6 times 6, is the next one above it. So the square root of 25 is 5, and the square root of 36 is 6, and the square root of 28 is going to be somewhere in here between these two whole numbers. Anything between these numbers can be written as a decimal. The whole number will always be all the way to the left. So I'm going to know that the square root of 28 is going to be about, that's my symbol for about, and I'm going to say it's going to be about 5 point, and now I have to decide what my decimal is going to be. So would the square root of 28 be closer to 25, or would it be closer to 36? First, to find that, I usually try to look for about what's in the middle of these two numbers. So between 25 and 36 is going to be about 30, a little bit more than that. So 28 is going to be less than half. So I'm going to write it in about right here. And this is estimation. It's not perfect, but that tells me that if this was half and 28 was about halfway between those two, that my thing is probably going to be about 5.25 or 5.30. And so that would be my final answer. I'm estimating that the square root of 28 is about 5.3. If it asked you to estimate it just to the nearest integer, then I would just say 5 because it's closer to 5 than it is to 6. And a number line can be helpful with finding these. All right, more important vocab to know. So all rational and irrational numbers are called real numbers. And remember, that was the title of this chapter, is we're going to learn all about real numbers. We've already learned about rational numbers, right? Rational numbers are all fractions that have any whole number as the numerator and don't have 0 as the denominator. It has all decimals that are repeating or terminating. It has all whole numbers. It has, pretty much everything we usually work with is a rational number. Perfect squares are rational numbers. So this word, irrational numbers, you probably haven't learned much about this before. These numbers are not used often, but we do need to know what they are. So irrational numbers are numbers you can't write as a fraction, repeating or terminating decimal, and some examples would be such as pi or the square root of 1/5. If this was the square root of 16, that's rational because the square root of 16 is 4. But any number that that's not a perfect square and is the square root of it, or when we're looking at a number like pi 3.14, blah, 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 goes on and on and on. It doesn't have a repeating pattern. We know that those numbers are irrational. So you're going to be asked sometimes to define whether or not the number is rational or irrational and explain it. Let's look at this one. A, 0.818118111 dot dot dot. It means it goes on and on and on. All right, you realize that there is a pattern here, but is it repeating? The answer is no, because I can't draw a line over one bar and it's just going to continue to say 81818181. It keeps adding another one, so it's not repeating. It doesn't terminate. It keeps going on and on and on. Therefore, this is irrational. And I'm just going to abbreviate it like that, and I'm going to say it is irrational because it is not repeating or terminating. All right, let's look at example B. So here we have negative 0.18 repeating. Well, because this decimal is repeating, I know that it is rational. All right, down here, the square root of 5. Well, it is a square root, and is it a perfect square? No, so it is going to be irrational because it is not a perfect square. Okay, here we have 1 2/9. Well, this is a mixed number, and it's written as a fraction with a whole number there and not a zero there, so this is rational. Finding a square root is the inverse of squaring something. So that means that we can undo finding the square root of something by squaring it, or we can undo squaring something by finding the square root of something. This is helpful when we are evaluating equations. So here we have 16r squared equals 64. Right now, r is what I want to get by itself. It is being squared, and it also is being multiplied by 16. Because I am going to undo this in the opposite order as PEMS asked, because I'm trying to get r by itself, first thing I'm going to do is divide by 16. And then I'm going to divide by 16. So what's left is r squared equals 64 divided by 16 is 4. Now I have r squared equals 4. R is still not by itself because right now there's r times r over here. And I'm going to undo this by finding the square root. I draw it right through that to show that it crossed off, and I do the same thing on that side. So r equals the square root of 4, which is a perfect square, so I'm going to simplify it to 2. Sometimes I might leave it as under a square root, like if it said r equals the square root of 15. Sometimes I might leave it if it's because that's considered simplified. Other times I'll make it a decimal and I'll round it to whatever they tell me to round it to. All right, let's look at example B. So 48 equals 16t squared. So, ironic, this one is being multiplied by the same number. So I'm going to divide by 16 and divide by 16. 48 divided by 16 is, now I have 3 equals t squared. And so to undo the squaring, I'm going to take the square root of both. And I have t equals the square root of 3, or t equals, and I would only find this by using a calculator. If I plug in the square root of 3, then it will simplify it, and I can say that the answer t equals, or is about, because I would definitely need to round this, 1.7. All right, there you go. That is everything you need to know on exploring square roots and irrational numbers. Go ahead and get to work.